Swayam Prabha. Digital India. Educated India.
So, welcome to the NPTEL course on building energy systems and auditing. Today is the last lecture on the module number 1. So, that lecture will be on the psychometric operations. So, in that lecture we will start with the air and its properties, which has already discussed in the last lecture on the previous lecture on the ventilation. We will discuss the concept of enthalpy and also we will discuss the psychometric chart and its operation, of course. So, we have discussed two major things, one is the dBT and the WBT in the previous lecture. So, next is the humidity ratio. The humidity ratio defines as, suppose in a particular mass of air at a certain volume of the air, what is the total ratio of the mass of the humidity, that is mass of the moisture, and the mass of the sample, that particular dry air. So, as we discussed already, there is a 3-phase diagram where we have empty spaces and there are two substances, one is the air molecules and another one is the molecules of the moisture. So, what is the ratios or of that? That is the humidity ratio, which is also going to play a very vital role, and the absolute humidity. Absolute humidity is a kind of a density. We can say also that is a water vapor density. So, how much kg of water or the moisture is there in how much meter cube of the dry air, that is the absolute humidity. So, suppose we have a temperature 15 degree centigrade. We have some 20 air molecules and we have some 12 space for the moisture to be retained in a particular state of some 1 meter cube or whatever a particular 1 meter cube the air. Now, let us suppose, just for our understanding, let us suppose those molecules of the air is having 1 gram of weight and 1 molecule of those, if there is any 1 molecule of the moisture will have the 2 grams of weight. So, at that particular point, suppose I have out of the moisture space which is 12, 3 spaces are filled with the water. Okay. So, there are 3 molecules of water and there are 20 molecules of air. If you count number of green dots, they are 20. If you count number of the yellow dots, they are 3. So, that means, if the humidity ratio I have to find out, so I can say how much is the total weight of the water molecule. There are 3 into 2, so 6 grams. There are 3 molecules each of 2 grams. And how much is the total dry air? So, there are 20 such molecules and 1 gram, so 20 grams. So, 6 by 20, so 0.3 gram per gram of dry air will be the humidity ratio. Whereas, so absolute humidity will be 6 gram of water per meter cube of the air, because I thought that this is I have assumed that this is 1 meter cube of the air. So, 1 meter cube of the dry air is having 6 gram of the water. Similarly, if the number of molecule increases, now there are 9 molecules, there are 3 empty spaces, your humidity ratio will be 18, which is 9 to the 18, and 20 grams of air will be remain as same, because I have not increased the number of air molecules, that is remain as 20. So, 0.9 gram per gram dry air. So, that is the humidity ratio. So, definitely humidity ratio increases and absolute humidity is also increases, because 18 gram is now the water weight divided by the 1 meter cube of the air. So, next is the specific volume of the air. That is a very straightforward the definitions. So, that is a how much meter cube of air is actually going to have in 1 kg. So, of the dry air or so. So, it is a, you can say it is a reverse of the density kind of a specific volume, reverse of the density. Density we sometimes we say that is kg per meter cube, it is just the opposite, meter cube per kg. So, how much meter cube of the air is actually occupying a space, how much meter cube of that volume if the air weight is 1 kg or so. The next is the relative humidity. We have started discussing on that in the last lecture also. If you remember the dBT, WBT drop and all. The relative humidity by definition refers as the water vapor pressure or water content or vapor content in a air expressed as the percentage amount the moisture it can retain in the atmosphere at a given pressure or temperature. So, that means at a given temperature and the pressure, air has some quantity of empty spaces, how much percentage it is filled with this vapor or the moisture. So, that is if it is fully filled, we can say it is 100% relative humidity, if it is very less 10% or so. So, here you see I have the same the 3 phase diagram where 20 molecules and 3 of them are filled with the water, 20 molecules of air of course, there are 9 spaces of the moisture and 3. So, that means relative humidity is your 3 by 12 because 3 by 12 because there was 12 spaces of the molecules, out of that 3 is filled. If it is increases, so now it is 9 by 12, so it is almost 75% RH. If you remember there are 12 such spaces, out of that 3 are filled and 9 are empty. So, 9 are empty and 3 are filled. So, total amount of spaces will be 12. So, for every cases, next case also it is always going to be the amount of capacity is 12 and now how much you are filled, only 3. So, 3 by 12 25%, this is your how much 9 by 12, this is your 75% and this is whole filled. So, 12 by 12 100%. So, there is after this there is no space available. So, 100% relative humidity is moist water, moist air, the air is fully filled with the moisture, the whatever the retaining capacities are. So, now the enthalpy. The enthalpy is a concept and it is a kind of a defined as it is the internal energy of any such product, particularly we will say here for the air. So, air has a sensible heat component because it has some kind of heat, it may have 15 degree or 20 degree whatever. So, that actually contains some kind of a sensible energy in it and also it has some amount of moisture in it and the moisture is having some kind of a latent heat component. Okay. So, if I want to, so it has some kind of a energy state, suppose maybe it is E1. So, that is its enthalpy and now if I want to increase the temperature from 15 degree to 20 degree centigrade or so. So, definitely there is a sensible heat change. I have discussed in the earlier lecture, the temperature change will be definitely going to be governed by the sensible heat input or output. So, if there is a 15 to 20, there is some input of the sensible heat and suppose there is a moisture change also. So, there is a either some latent heat in or latent heat out. So, depending upon your relative humidity changes or whatever. So, that will give you some kind of a total state of energy to E2. So, what is the difference between this E1 and E2 is the enthalpy difference between these two coordinate of the air. So, as I have discussed these two, so we can find out the enthalpy HA plus X times HW. HA is the specific enthalpy of the dry air which is sensible heat point of view, X is the humidity ratio and WH is the specific enthalpy for the water vapor. So, broadly it is classified in this. So, if I know this is another equation we can actually use for to find out the enthalpy, how much is the enthalpy in kilojoule per kg or whatever in that particular unit. So, it is an energy unit, so it is in kilojoule per kg of air. So, if I know the dBT, if I know the HR is the humidity ratio, so I can use this equation to find out the enthalpy. So, I have calculated. So, if you can check it with the 25 degree and some humidity ratio, the enthalpy is coming out as to be 5.57. So, you change it, if the dBT you change, that means you are changing the sensible heat plus or minus whatever. If you change the HR plus or minus latent heat, so you will get to have, you will get a new amount of H, that is the enthalpy. So, you can use this particular psychometric property calculator. So, if I go to to that particular. So, this is that particular psychometric calculator. Suppose I give some 30° drive up temperature, and if I give wet bulb temperature, of course, will be little less than that. See, if I give suppose 28°, so the relative humidity is see very high, almost 86%. And if I say suppose wet bulb temperature, if I give 30°, so definitely the relative humidity will be your 100%, because that is saturated. So, suppose if I go to some 20, or if I just suppose reset, and suppose if I give this is 35°, and we usually give relative humidity suppose 70%, 35° dBT the temperature of the air and 75% is the relative humidity. If I go for calculation, so I can get the enthalpy as 99.78 kilojoule per kg. We can find out the humidity ratio as 0.0252 kg per kg, and also you can find out the specific volume as 0.009 meter cube per kg. So, this is a you can do it, otherwise you can do it from the psychometric chart, we will discuss that one. So, let us go again to the PPT. So, you can use this. So, you can actually use this one. So, I have shown you. Now, otherwise you can go to the psychometric chart. In the psychometric chart, it has broadly two axes. The x axis stands for the dBT. So, if I have some dBT or some dBT, if I want to place, I have to see or check the x axis, and the y axis stands for the WBT will be in that curved line, and it will be inclined kind of a thing. These blue lines are for the WBT, representing the WBT. So, any cross section is the WBT dBT your this particular WBT dBT or particular combinations, and the y axis is your humidity ratio, right. The y axis is your humidity. So, x axis is your dBT, y is your humidity ratio HR, and this curve axis and this inclined lines are the wet bulb temperature. In this there are so many other lines also. There are these way, there are some curved lines are there, that will follow the final curved line. Those are the RH lines, so humidity ratio lines. So, lower will be your less, suppose this is 20%. So, let me take, so this is your suppose 20%, this is maybe of 60% RH or something like that. And enthalpy lines are almost parallel to the WBT line. So, that line will actually give you the WBT enthalpy, and there are other lines which is another directions which is giving you the specific heat. So, in nutshell what I am going to see in a particular, suppose if I just go a little bit forward to a particular psychometric chart, see in the x axis I am getting WBT, y axis I am getting humidity ratio, these are my wet bulb temperature, this is the enthalpy scale, these are the enthalpy scale, these three or two scales are there, and these are the specific volume. Okay. And these curved lines are your relative humidity, this 10%, 20, 30 like that, and finally, the last one is your 100%. Okay. So, now if I go back to the next slide. So, if I know, if I have some data of a air, that how much is the dBT and how much is the RH, I can plot one point. So, any one point if I want to plot, I need two data. It is a 2D graph. So, I need to either I need humidity ratio and the dBT, or I need the WBT dBT, or I need RH and humidity ratio. So, best what we actually get it from the hygrometer is that is the dBT and the RH. So, let us plot one point. So, after you got a point, you are going to know lot of things about that particular state of the air. You can actually go like this, and to the WBT scale you can find out the WBT. You can go to the enthalpy, how much is the state of that particular air has having how much kilojoule per kg. You can go right hand side to get the humidity ratio. You can find out how much is the specific volume. So, once you get a point, you can get all the data. And once you get another point, suppose from this point I have to go to some other point or so. So, I will get lot of data and I can find out the what is the difference of the enthalpy, what is the difference of the humidity ratio. So, like that I can find the difference of the dBT, find the difference of whatever, and then I can actually get to know lot of about lot of the things. So, I can also find out the dew point temperature by going straight, striking to height 100% RH line and drop back to the dBT line. So, the dew point temperature is also can be measured. So, here in the, and now suppose we let us discuss a little bit on this relative humidity and the temperature. Suppose in 15 degree temperature, which I have started since last class, last lecture, we have 20 air molecules and we have 12 spaces available. If I increase the temperature, what is going to happen? The intermolecular distance of the air will going to increase. Okay, so, whatever may be there, maybe 1 inch or something, now it will be 2 inch or something. So, in between now there are more air molecule can be fit in. So, in if there is a dry air, no molecules of air water is there, it has 12 space. At a time when there is a 15 degree temperature, if I increase the temperature to 25 degree, number of air molecules suppose remains same, because the volume is remains same, I am not giving any more amount of air molecule. So, they are 20, but the space of moisture from 12 to that may increase to 16 because of the intermolecular distances are more. Now, 1 meter cube will be now maybe 1.2 meter cube, volume is increased because of the temperature has been increased, Charles' law. Now, next is in the 15 degree temperature, I have 12 molecules and I have suppose 6 molecules of the air, then I have 50% of RH, right. Now, if I change the temperature, so what happened? This same the same amount of water molecules are there 6, but now the total space become 16. So, the RH become 37.5 degrees. So, what we understand is that if the humidity ratio remains same, no new air molecules are get into the air space. Because of the temperature increment, as the volume is higher, volume is increased. So, the intermolecular distances are increased, there are new spaces available for the air moisture, the RH or the relative humidity is decreasing. But we have same humidity ratio, because we have 20 grams of dry air versus 12 grams of moisture, here also in 15 degree, other side also 15 degree. But as the RH decreases, because you have now more space to fit in, right. So, that is one of the very important things. So, if the dBT changes, that means sensible heat changes from one place to other, you see at this particular point you have 60% RH, you do not have any change in the y axis, that means your moisture content or the humidity ratio remains same, but your RH decreases, it is something like 30% now. So, what we have discussed, in higher temperature volume increases, Charles' law, number of air molecules remains same, moisture holding space increases, humidity ratio remains same axis in the y, same axis y axis, it is not going to change from here to here. Absolute humidity ratio decreases because volume increases, and relative humidity decreases because your these two lines. So, from here to here it is a below line, so it is 60 degree, it may be 40 degree also. So, it is decreases. So, that we need to understand. Next is, if we are not going to change that, suppose you take this blue line, we are not going to change the dBT, we are changing the humidity ratio. As and when we are increasing the humidity ratio, your humidity ratio is increases, and more humidity filled more spaces, and it is leading to from 0 to maybe the 100% of the relative humidity. Okay. So, that is obvious, but the amount of 15 degree, amount of space is less. So, it will be very quickly it will be of, it will go to the 100%, which may be around 0.01 or something, but in case of 25 degree you may require 0.02 or something like that at 2. So, you require more amount of moisture to make it 100% RH if the dBT is higher, right. So, that also qualifies whatever we have discussed in the last. So, suppose I have taken example. So, the dBT is 40% and the RH is 50%. So, what to do? I have to plot a point. So, that point is dBT 40 and this line, this line, this line, this black line is for 50%. See, I have marked in the red circle. So, this point is ready, and as and when this point is ready, I can know lot of things from here. I can see, I can find out the WBT is 30 degree, because this is, I told you, this is the WBT scale, this 20, 15 or whatever. I can also find out the dew point temperature, which is almost about 27 degrees or so. I go straight way to strike this 100% saturation line and drop back, drop to x axis to almost about 27 degrees or so. I can find out the humidity ratio, which is 23.5 gram of moisture of dry air, and I can also find out the enthalpy, which is always going to be almost parallel to the WBT line. So, which is striking to almost about 100 kilojoule per kg per dry air, right. So, I can find out the what is the SV ratio, that is a specific volume, which is 0.92 meter cube per kg of dry air or so. So, by virtue of two given data, I first find out one point in the psychometric chart. I will give a psychometric chart in that our forum. So, you can use that one, you can take the print and you can use that one, or you can use that particular website, which can be directly give you those kind of air properties based on two given data. So, any two given data is required to get first point, and that point now gives you other datas. And why we always go with the WBT and the RH is because hydrometer will give you these two data. It is giving you the air temperature, it will give you the relative humidity. So, it is always better to plot the data or get the data point, plot the point, the particular point of the air state, or by virtue of the dBT and the RH. Of course, in the some of our questions, some of our assignment, we may give some other WBT and RH also, or WBT or dBT also, that is immaterial, but at least you require two data to plot a point, and other data can be found out from the other from that point onwards, and you have to please try to maintain the axis, which axis belongs to whom, that you need to know. The inclined axis is both that WBT and the enthalpy. The other inclined axis is your specific volume. The y axis in this side is going to be your the humidity ratio, and dew point temperature also you can get, and those curved lines you have to actually see for your RH. Now, you see I have actually plotted that one. I just in that particular psychometric this particular website I can go. My data was dBT 40 and RH is 50. So, I have plotted that one here, dBT 40 and the relative humidity 50, these two are my input data, and I calculated there, and see I got this 100.81 as a kilojoule per kg as a enthalpy, which was 100 measured in the psychometric chart, very close. Humidity ratio is measured exactly same. It is given, you see it is given as kg per kg, but in the psychometric chart which I have used, there it is given 23.5 gram moisture. So, it is exactly the same. Specific volume, here it is given 0.92, I also got 0.92. So, it is almost the same. Wet bulb temperature is your 30.31 degree, I think I also got 30 degree, let me check, yeah 30 degrees. So, it is almost same. So, either of these two ways we can find out the properties, but try to do with your this thing the psychometric chart, get some printout, it is also available in the online sources. You just give the psychometric chart, printable psychometric chart, but you see the SI unit. There are other charts also, psychometric charts based on the the foot pound unit also. So, better, or Fahrenheit degrees or whatever. So, better to take the SI unit one. So, next one what I see. So, if I know, suppose the outdoor temperature of a volume V and the RH is this much, RHA. So, I can plot with the temperature dBT TA and RHA a point A, right. Similarly, I can plot another point B if I give you another set of data that the dBT of the particular air has to be little bit cooler, TB, and relative humidity also may be little less. So, that is RHB. So, imagine suppose it is very humid and very high temperature air outside, which is maybe 38 degree and 80% humidity, which is maybe this one, maybe I can say this is 38 degree and 80%. So, your represent this particular point A, and I want to cool it down to maybe 20 degree centigrade with suppose 30% RH. So, that will be little less amount of the dBT, which is this, and that will be represented by B. Now, this 2 point has its own values, right. It has its own enthalpy value, it has an own the HR value, it has its own SV values also. So, if I see I want to come from the, I am to transfer the A to B, that means that much 38 degree of V volume to 20 degree of same air I have to convert. So, I have to actually use some kind of a energy which actually required to be in chiller plant or some plant of the air conditioning plant. So, this how much is the delta E? So, it having some kind of the enthalpy value for A, suppose I may say this is the E A and this is my E B. So, this delta E is my E A minus E B, that I can find out. So, I know that this is my change and this is kilojoule per kg. So, if I can multiply with some V or rho, that is the suppose meter cube by kg is my this rho, can I, if I multiply with this kilojoule per kg, which is my enthalpy del enthalpy, and if I, this is what is V? V is a volumetric rate, meter cube per second. So, if I can make it like that, so I can easily find out rho is your kg per meter, I am sorry, this is rho is your kg per meter cube. So, this is the density, this is the volumetric the air exchange rate also, and this is enthalpy. So, this kg cancels, meter cube cancels. So, this gives me kilojoule per second, which is your kilowatt, right, kilowatt. So, I can find out this Q as a kilowatt. So, if I know that, I can actually find out that how much is the energy required to cool down some amount of air from one state to the other state by virtue of the psychometric operation. So, that ends the lecture of this module today, and This is module, first module is over, then we will go to the next module with some other chapter. The chapter will be your building energy systems. In that we will start with the HVAC systems, and again we will continue with the psychometric operation for that. So, what we conclude today in this particular lecture as state of air is always described by the moisture content and DBT, particularly DBT and the RH. We can consider the sensible and latent heat for any such changes, because that changes actually reflected by the enthalpy, and the state of energy of a particular air at particular time with some DBT and some kind of volumetric moisture content gives the enthalpy. Psychometric chart provide the interrelationship of the DBT, WBT, RH, moisture content, enthalpy, and by virtue of that we can actually find out how much is the energy required from one state to other state of the air. Thank you very much.